Good morning, guys. This is Mr. H. Hey, I am going to make a quick video on adding and multiplying rational and irrational numbers. So, you're going to need your note cards. So, if you do not have your note cards, stop this video, go get your note cards, and then resume. If you don't have note cards, either ask one of your classmates or ask Mr. H for note cards. You're going to need note cards for this. I'm just going to go through 6 rules, and I'm going to go quickly. If you need to, stop the video, write the rule down on your note card. Remember, when you're making these note cards, you're going to make them into questions. But I'm going to just go through each rule, and I'm going to give a couple examples. All right. So, and I'm going to start with the easiest ones that are always true, and then we're going to get to the ones that are mostly true, and then we're going to get to the ones where you have to think about it. So, very first thing, whenever you add a rational number to another rational number, you will always get another rational number. Here's an easy example. 2 plus 3 is 5. Those are all integers, so we're good. 2 plus $1.50 will be $3.50. Those are also rational numbers. All right. So whenever you add 2 rational numbers or 3 rational numbers, you always get another rational number. All right, let's move it. Second, when you multiply 2 rational numbers, you will always get another rational number. We'll go same example. 2 times 3 is 6. 2 times $1.50 is 3. Those are all rational numbers. So whenever you multiply rational numbers, they will always give you another rational number. Okay, now we're going to mix them, but this is always going to be the case. If you add a rational number, or if you add a rational number to an irrational number, you're always going to get irrational. So if I do 2 plus the square root of 3, this is going to be 2 plus the square root of 3. We know that the square root of 3 is irrational because 3 is not a perfect square. So that's going to be a decimal that goes on forever. When I add 2 to that, it's still going to be a decimal that goes on forever. So this is always going to be true. Okay? Same thing. If I subtract, this is also going to be an irrational number. So whenever you add or subtract rational and irrational numbers, you're always going to get another irrational number. All right. Now, these are the ones that you have to think about a little bit. All right, here. When you multiply a rational times an irrational, do you always get an irrational? And the answer is no. And the reason is, if the rational number is 0, then you're going to get 0. So if I do 0 times square root of 5, that's going to be 0. And that's not a rational number. But if you don't use 0, then this will always be true. Let me say that again. If the rational number is not 0, if it's any other number, let's say 3 times the square root of 5, now that will be irrational. So as long as the rational number is not 0, it will always be true. This will always be true. A non-zero rational number times irrational will always give you an irrational. That's true. That's true if that number can never be 0. Okay? Make sure you remember that. It has to be a non-zero rational number. Okay, let's go to the next one. Next one, same thing. We got, is an irrational plus another irrational, is that going to give you an irrational? Most of the time, it will. So if I do the square root of 3 plus the square root of 5, I'm going to get another irrational number. I don't know exactly what it is until I calculate it, but it's going to be another irrational number, right? This is going to be irrational. Now, we don't have to calculate these. You're never going to have to calculate these. What you will always be asked is they'll give you 2 numbers, and then they're going to say, is this irrational or rational? And you have to justify why it is rational or irrational. They're not asking you to calculate. Okay, so if I say the square root of let me say, square root of 10 plus the square root of 21, you should say, oh, that's going to be irrational. Now, the reason that we can't say always, and this is again kind of a fluky example, but if the irrationals are opposites, then they're going to cancel out and you're just going to get 0. So the square root of 3 plus the negative square root of 3 is going to be 0. So this is irrational. This is irrational, but because they are opposites, they equal 0, which is a rational number. Now, this is the only time that it doesn't work. So if the irrationals are opposite, then you're going to get a rational number. But that doesn't happen very often. Most of the time when you're adding irrational plus another irrational, it's going to give you an irrational. The only time that it doesn't is when they are opposites. Make sure you got that. Now, here's the last rule. An irrational times another irrational. Now, this just depends on what the irrationals are. You have to look at the irrationals, multiply them together, and see if it's a perfect square. So let me give you an example. So if I do the square root of 2 times the square root of 8, right? Now, this is irrational because this is not a perfect square. This is irrational because it's not a perfect square. But when we multiply these two together, 2 times 8 is equal to 16. This is a perfect square. So in this case, if I multiply two irrationals together, I get a rational number. Now, let's go to another example. If I do the square root of 2 times the square root of 3, I have 2 times 3, which is 6. 6 is not a perfect square, so this would be irrational. Now, you don't have to actually calculate anything except what's inside the square roots. If those two numbers multiply to a perfect square, then it's going to be rational. Now, you should know that from the previous video that any square root of a perfect square is always going to be a rational number. So if you don't have that as a note card, you should make that a note card. But this rule, it just depends. You have to look at what those two numbers multiply to. If it's a perfect square, then it's rational. If it's not a perfect square, it's irrational. Those are the rules. Those are the note cards that you need to create, and you need to understand them. You need to understand, especially this one, what makes the difference, what makes it rational versus irrational. All right, guys, that is the lesson for today. You just have to know these rules. So make your note cards, study your note cards, then you'll be ready to answer any question. All right, thanks.